The purpose of this screencast is to learn how to implement a Java program based on a UML diagram. And for the sake of this screencast, I've created the small UML diagram that you see here to the right. Here we see that we have three classes. We have an enrollment system class, we have a course class, and we have a student class. Now, before we start and implement, let's see what we can see from the UML diagram, and let's also identify the things that we are unable to see from the UML diagram. Now, obviously what we can see here is that we have three classes that we'll need to implement. We also see that each of these classes have some attributes and some methods. We see, for instance, that we have the student class, which has a name attribute. It is private. We can see that from the small minus in front of the attribute. And we also see that it's a type of string. So this gives us pretty much the definition that we need in order to define this attribute. Now likewise, we see that student has a couple of methods, 3 to be specific. It has a getName method. We see that this is a public method. We can see that from the small plus to the left of getName. And we also see that this method returns a string type. This pretty much gives us the signature that we need, or the definition that we need for our method, because now we see that it is a public method that returns a string, and it's called getName, and it has no attributes. So we can see here what are the attributes that we have for each class. We can also see what are the methods that we have in each class. So what are the things that we cannot see from this class diagram? Well, one of the things we can't see is we can't see the constructors here. So here we will have to draw on our knowledge and our expertise in programming in order to define some constructors that make sense. Another thing that we are unable to see from the UML diagram is the implementation of each of the methods. Now, as we've learned about encapsulation and know how to encapsulate our attributes, we also know that a method such as getName is a method that will likely just return the value of the name attribute in student. But we also see that we have other methods such as enroll, and if we don't have any other description than the UML diagram, which would in a real case scenario be very rare, then we would have to infer based on the naming of this method what is the purpose of this method, and based on the purpose of the method, of course, we will have to implement some appropriate program logic. Now with that in mind, let's go ahead and start implementing. Now before we can implement, there's just a final thing that we need to consider, and that is, where do we begin? Now a good rule of thumb when implementing based on a UML diagram is to pick a class that has no dependencies towards other classes that we need to implement. Now if we look at course, for instance, we see that course is depending on student, which means that if we were to start out programming course as the first class, then we would have some broken logic in our code because we would be depending on a type that does not exist. Now if we instead select the student class, we see that we depend on string, and we see that we also depend on int, but both of those are provided to us through the Java framework, and so they should be easily accessible for us once we start programming, and we can build the complete student class independent of the other classes, and then take up course as the next class to implement, because then we have the student class and we can use the student class over in our course class and so forth. And that means that all the way through we can build programming code that is sound and which does not have some errors that we will have to return to later. This of course also means that we're able to test our code as we go along if we wanted to do that, and for larger systems that would be a good idea to do in itself, but for the purpose of this screencast here we're not going to do stepwise testing. Instead we're going to test once we're done implementing. With that said, let's start out implementing. Now I'm going to go ahead and start a new project in my IntelliJ IDE, and we are going to just create a standard new project from project template, command line app template, because that will provide us with a main class and a public static void main method that we will use later. We are going to call this UML implementation example. and we are ready to start out. So as we'll see, in our source folder here, we have the main class already. And now I'm going to go ahead and start out creating the student class. I'm going to right click here, choose new Java class, write student. And so based on our inference from the UML diagram, we see that we have the name attribute, which is private and of type string. So I'm going to write private string name. And we also have a private int ID. Further, we see that we have three methods. We have a public string getName, and we'll go ahead and implement this immediately. We know that this will just return the value or reference to the name attribute, actually. And we are going to write public int getID and return the value of our ID attribute. And we're also going to implement the toString method. Now, the toString method, as we know, is something that is defined in the object class, which means that we override it here in the student class. Now, I could just go ahead and write public string toString this way, and this would effectively override the toString method of the object class. But as we know, it's a good idea to annotate this with the override attribute, or annotation, sorry, and we'll go ahead and use that. And in here, we are going to return this.name plus this.id. This will give us a very simple representation of the objects in string form, the student objects in string form. Now, the only thing that we're missing now in our student class that we cannot infer from the UML diagram is the constructor. So I'll go ahead here and define a constructor that is sound for this kind of class here. And so we have two attributes. We have a name and an ID attribute. And so I'm going to go ahead and define a constructor that is able to assign an initial value to our name attribute and to our ID attribute, like so. And with this, we're actually done with the implementation of our student class. With our student class implemented, we'll go ahead and focus on the course class. Now, the reason that we're focusing on the course class is, as I mentioned previously, that the course class is depending on the student class, but it's not depending on any other classes that we need to implement, which is why we would choose that or the enrollment system, which both depends on the student class and the course class, and so cannot be implemented with functioning code until we're done with the course class anyways. So we'll go ahead and implement a new class that we'll call course. And of course, this name is something that we have inferred from the UML diagram. Now, the course class we see has three attributes. It has a private string name attribute. It has a private student array participants attribute, and it also has a private int student participant count. Aside from that, it has a public method, accessor method for the name attribute, public string getName, and we'll go ahead and implement this immediately. It also has a public student array get participants. Now, for this one, we're not going to just use a trivial implementation, because what we want to ensure here is that we return a copy of the array of participants that we have on the course, so that we don't have any other classes interfering with the actual participants of this course, but rather just get a mirror or a image of the current participants in this course. Now, in order to do that, what we need to do is we need to create a new student array in here to hold our result. Now, the size of this student array, we're going to make it participant count large. And that's because at a later stage you'll see that the participant count attribute is going to hold the actual number of participants in this course here. Now, of course, we're not done with this. We need to copy the contents of the participants array into the res array, and we're going to return the res array. So in order to do that, we're going to create a for loop, and we're going to declare a variable I, initialize it at value 0. We're going to put up the condition that I has to be less than the participant count, and we're going to count up I once for each run through. Now in here we're going to write that the res position I is going to equal the participants count I, like so, and then finally we're going to return res to whoever's calling this method here. Now we still have a couple methods to go. We also have an enroll method. Now this method is a void method called enroll, and it takes a student as an argument. So of course the purpose of this method is to enroll a particular student into this course. Now how are we going to do that? Well, for one, we need to make sure that the student is added to the array of participants. So we're going to write participants add participant count is going to be equal to s. Now, why is this the case? Well, this is because the participant count is the number of participants up until this student has been added. This means that the amount of places in the array that is filled is equal to participant count minus 1. Well, that's not true. The amount of spaces is of course participant count, but since we're indexing from 0, this means that there is a student up to participant count minus 1 before we add this student. So we can safely add this student to index participant count, and then just make sure that afterwards we increment participant count. So now we have added the student to the participant array, and we have also incremented the participant count with 1, which means that we have effectively enrolled the student into the course. Now the final thing that we need to do with respect to methods in this class is we need to override the toString method. You can see that from the UML diagram, where we see that there is a public toString method that returns a string, which means that this is effectively overriding the toString method of the object class. So we're going to override this here, and the string representation of these objects is going to merely be the name of the course plus the participant count. All right, and this was it for the methods in the course class. The final thing that we need to do is we need to create a constructor. So we're going to create a constructor, and this is actually only going to take a single argument, despite the fact that we have 3 attributes. And this is because the only thing that we want to allow external users of this class to define is the name of the course, because we want to initialize the participant array ourselves. And here I'm going to put an arbitrary number. Of course, in a practical sense, this is not arbitrary. I've chosen 150, which means that as the current implementation of this class goes, objects of this class will support 150 students, which means that you can add 150 students to your course objects. Is that enough? Well, maybe it is, maybe it isn't. But this, of course, has to be inferred based on the specification of the program, so that we're sure that we chose an appropriate number here. Of course, we could also have added some logic that automatically shrinks or expands the array based on the amount of participants. Just notice that every time a programmer has to do something, it costs money. And we do not want to spend money that we are not paid to spend, which means that if there's no requirement for anything else than 150 students, well, this might be the appropriate way of implementing that requirement. I'm also going to initialize the participant count to 0 because we'll assume, or well, we know actually that there are no participants when an object of the course type is created. And that's it for the course class. With the student and the course class in place, it is now time to focus on the enrollment system class. Now we'll start out by creating a new class and call it enrollment system. Now our enrollment system class has two private attributes: private student array, students, and private course array, courses. It has a public method called public void create course that takes a string as an argument. Of course, this string is going to be the course name. Now we know that the constructor in our courses only take a name as an argument, and the rest of the attributes are initialized silently by the constructor. We cannot interfere with that from the outside, so we will go ahead and create a new course and just pass on the course name attribute. And of course, we need to add the course to our courses array. So where do we need to put it? Well, we will need to put it at a position that equals the amount of courses that we have already added. This also means that we will necessarily need another attribute that we were not able to see from the UML diagram. And this is sometimes the case, that we will find out that once we're implementing stuff from a UML diagram, we will need additional things that was not described in the UML diagram. Because realistically, a UML diagram will never be at a detail level where we have everything that we need, and that is especially true for complex systems. So we're going to create a course count variable here, and we're going to put the course at position course count, and then of course we need to increment the variable course count in order to keep track of how many courses have we actually created. Now we're also going to create a method public void add student, and we see that the add student method takes a string. This is the name of the student, and this means that when we are creating a student, we know that the constructor that we created here in student takes a name and an ID as arguments. So this means that our enrollment system, since this has a method here that only takes a name, down here in the method body we need to decide on a student ID. We're going to use a simple student ID in this case here, so we're going to create another attribute in here that we are not able to infer from the UML diagram, but we will see shortly that we need this one anyways. And we are going to use the student count as an ID for our student. So this means that we will go ahead and create a student S. And we're going to pass to the constructor the name that was passed as an argument through the add student method, and we're going to also send the student count as an ID. Now this solution will only work if one of two things are acceptable to us. One is that we can never remove students from the systems again. Once a student is added, we cannot remove the student, which means that our student count will always increment. If that is not true, we will come into a situation where we might have duplicate IDs across our students, because if we remove, say, the first student that we ever added to the system with ID 0, well, then we will decrement the student count with 1, of course, and then when we increment it again because we added a new student, we will have 2 students with the final student count number as their ID, or actually the final number minus 1, because as we'll see shortly, once we add a student and we have added the student to the students array, we will go ahead and increment student count by 1. Student count, like so. Oops, and up here, of course, I need to put something on this place in the array. And of course, this is my newly created student object that is referred to by the variable s that I created up here. So now we're able to create a course. Now we're able to add a student. Now we need to be able to enroll a student. Oh, sorry, to enroll a student, into a course. Now we see that we have a method over here called enroll that takes a string and an int as arguments. Now we do not know what this string and this int is based on the UML diagram. So here we would either have to confer with the person who created the UML diagram or draw on our own expertise. Well, since I've created the UML diagram, I also know that the string is actually the name of the course, and the integer is the student ID that I would like to enroll into that course. Now, this means that this method is not completely trivial. In order to implement this, first I will need to find the student with the student ID specified by the argument up here. How can I do that? Well, for one, I could traverse through the students array, and we can just do that with a trivial for loop. Like so. And we will check if students I dot get ID equals student ID from the argument. Well, then we found our student, and actually I'll go ahead and add a student local variable up here just to make it accessible outside of the for loop. Student to enroll. We'll give this a null value to begin with, and down here we found our student because the student at the spot I had the ID that equals student ID. This is the reason that we're branching in here. So we'll go ahead and say student to enroll equals students I. Now, since we found our student, we can go ahead and break out of this for loop, and down here we're going to check if student to enroll not null. This means that we found the student. So now we can find the course to enroll the student into. So we can do that with another for loop. This time we're going to traverse through the courses array. So I must be lower than the course count. I++. And down here we're going to go ahead and say that the course, if courses I dot get name equals course name. Well, in that case, we found the course that we would like to enroll the student into. So this means that we can go ahead and on courses at position I, we can call the enroll method with the student that we just found in our previous for loop. Now, here we are just going to print out a small message just to ensure that whoever calls this method is aware that the student is actually added now. And we can go ahead and break here as well. And we can also say that else, this is in the case where student to enroll is actually null and we didn't find the student, we could go ahead and print out a message saying that unable to add student to course, student not found. Of course, you could create other messages as well, but I think we will stick to these messages for now. So now we have the get name, the get participants, and the create course, the add student, the enroll method in place. So now we need to implement the show participants and the show participants method. And the show participant method takes a single string as argument, and we're going to assume that the purpose of the show participants method is to show the participants of a particular course. We're going to go ahead and say public void show participants, and the show participants takes the course name as an argument. Now we can go ahead and down here we can start by finding the course that we're going to need. Now we could go ahead and copy paste this up here, and I think that for the sake of this demonstration we're going to do that, but of course we're going to do something else this time. If we are able to find the course, we can go ahead and say that we would like to get a printout of the participants in this course. Now this requires us to go ahead and get the list of participants. So we're just going to do this in a bit of convoluted way, but also to make it more clear what we're actually doing. Participants equals courses I dot get participants. Now we're going to create a for loop here. For each student is in participants. Actually, this is a for each loop. Now, there's a particular reason that I'm using a for each loop this time, while I've been using a for loop the other times. And this is because, as we'll see in a short time, the courses array and the students array that we have in this class here is larger than the amount of students and courses, which means that we actually cannot just traverse all of the array. We need to actually stop once we reach course count and student count respectively. Now the participants that get returned from the courses, we recall that we actually copied the array, but we only copied the portion of the array that actually contains something. So if we go in here, we'll see that the get participants method was put into an array that had exactly participant count spots, and each of those spots were filled out, which means that we can now use a for each loop without encountering any null values. So we'll go ahead and get a text representation of each of the students. Now I can go ahead and just pass the object here, because this would be the same as writing s.toString, which we'll call the toString method on the student objects. The toString method is also called on the student objects if I leave this out. And we can safely do that because we know that we overrode the toString method in our student class, which means that we actually get a useful representation of our student objects this way. Now we are almost done with our enrollment system class. The last two methods that we are missing is the list courses method and the list student methods, both public methods and both with a void return type. So we'll go ahead and implement those. Public void list courses. So we're just going to quickly create a method that loops through the part of the courses array which is populated by actual courses, and we're just going to go ahead and write system out println courses I, which means that the course object on index I in the courses array is going to be, we're going to invoke the toString method on that, which means that we're going to call the method that we implemented before in our course class, the toString method over here, which means that we will get a sound representation of the course objects. Now we're going to do the exact same thing for the students. So I'm going to do a dangerous maneuver here and copy the code from above and replace it where I need to replace code to make it specific for the students. Now with this done, we're done with the enrollment system class. Now the final thing that remains for us is to test the system that we have implemented based on our UML diagram. Now, I'm not going to do a complete test of the system in any sense. This is merely for demonstration purpose and to show that at the surface level at least, our program seems to be working. So I'm going to go into our main class here, and I'm going to create an instance of the enrollment system by creating a local variable called enrollment system. And by the way, it just occurred to me that we are actually missing something, because over here in our enrollment system, we will need to add a constructor as well. Now, this constructor is going to be quite simple. It's not going to take any arguments at all. It is just going to initialize our attributes up here. And we will say that we have room for 1500 students in this enrollment system. Again, of course, this is a completely arbitrary number, and of course this needs to map to the actual requirements to the system. Now for the courses attribute, we're going to do something similar, and we're going to put a completely arbitrary number of 150, which means that this particular piece of software is going to support 150 courses. We're going to start the course count and the student count out at 0. And then we are ready to go into our main class here and test that our system is actually working. So we're going to go ahead and say that we want to add a student. Now we're going to call this student Paul. And once we have added a student, of course, we would like to list the students just to validate that the student has been added to the system. So we're going to go ahead and say that we want to have the students listed. And just as an initial test, we're going to run this program, and hopefully we'll see that Paul is being written out in string format. This is the toString method on the student class that ensures that we get this representation of our student object. Alright, with Paul now in the system, of course, once we run the program again, we can add Paul to a course, but before we can add Paul to a course, we need to add a course or create a course. Now, for the sake of this video here, we're going to call the course OOP. And now, once we have created the OOP course, we can go ahead and say ES list courses, just to validate that we have actually now both a student in our system and we also have a course in our system. And of course, both of them have ID 0 because that is how we assign IDs based on the number of entities in our system currently. So now with a course in our system, we can enroll a student into the OP course. And this student is of course the student with ID 0 because that is the only student we have. Now we want to make sure that the student has actually been enrolled in the course, so we're going to show the participants in the course OOP. So let's go ahead and execute this and see if our system works. So we see here that we actually get the status message on that the student has been added, and then when we're calling the show participants method with OP as an argument, we see that we get Paul with ID 0 as a printout, which means that yes, indeed, he has been added as a participant to the course OOP. This is it for this small screencast here, where we have learned how to implement the classes based on a UML diagram, and then also learned what are we able to infer based on the UML diagram, and what would we have to know ourselves through another source, either our own personal domain knowledge or based on knowledge of our co-workers that have created this diagram.